Here, before you say a word, do this with me. Press your hand flat on the table, lean your weight on it. It holds. Course it holds. It's a table, sitting there doing nothing at all, the way a table's meant to.
It's doing something flatly impossible, is what it's doing. That hand of yours is almost all empty space, a few far-flung specks and a great deal of nothing between them. And by every fair right, it ought to sink clean through the wood to the floor. Instead, it stops dead at the surface. You've leaned on that little miracle the whole of your life and never once looked hard at it.
Empty space? Stopped by more empty space? You're telling me my hand and this table are both as near to nothing as makes no difference. And the two nothings simply will not pass through one another.
They will not. And the one rule that stops them, that keeps your hand out of the table, that grants every solid thing its right to take up room, is the strangest thing in all of physics. It is also, and I mean this quite plainly, the very same rule holding up a dead star, against the whole crushing weight of its own gravity. I've kept it back from you a good while now, along with a fair few others.
Kept back? You make it sound like a cupboard of sweets you've rationed me since the leaves turned. Out with it then.
In its time. First, I mean to get you properly puzzled, because a man who isn't puzzled sets the answer down by the gate and loses it before he's home. And you walked in here dead sure you already know why a table is hard. That certainty is the very thing I've got to take off you before I hand you anything.
Stranger than a cat that's neither living nor dead? Stranger than a room that measures a thing just by breathing on it? You'll forgive me if I've rather stopped flinching this late in the winter.
I'll take that wager before the kettle's even warm. Here is the shape of the trouble, and hold still for it, because it ought to bother you a great deal more than it does. Everything I've handed you these 10 weeks has been about how flimsy the world is down underneath. Nothing sits still, nothing owns a settled where. The electron is a smear, and the atom is mostly empty room. Reach into an atom, and it's a speck of a nucleus, and a haze of almost nothing hung miles off, on the atom's own scale. And yet, you cannot push your finger through the table.
Say that last part again, slow, because I mean to catch you in the act of it.
The world down underneath is a smear, with no hard little thing anywhere in it. And your finger still will not go through the table. Both true, this very morning in the one breath.
Oh, that is rich. That is genuinely rich. You spend 10 weeks dissolving the solid world clean out from under me, telling me the chair I'm sitting on is 9/10 empty, and the other 10th is a rumour. And now you'd like a medal for explaining why I don't drop straight through it to the cellar? You broke the floor, man. You don't get applause for mentioning it's somehow still there.
I broke it honestly, and now I'll build it back honestly, which is the harder trade of the two. Because think what an atom actually is, nearly all gap. So what's the natural thing for a world of gaps to do? What would you put your money on?
If it's mostly holes, I'd bet the holes line up. One haze slides into the next, the gaps find each other, and the whole lot collapses down small. Everything sinking into everything.
Down to a point, near enough. That is the expected behaviour of a world this flimsy, everything falling in on itself. So turn it over in your hand a moment, because it flips the question inside out. It isn't the emptiness that wants explaining at all.
No, it's the solidity. With all those holes in it, my finger still stops dead at the surface as though it struck iron. That's the queer thing. Not that the table's full of gaps, that the gaps don't simply swallow me whole.
Now you've got the ache in the right tooth. Solidity is the miracle here, not the void. And to open it up, we start where we always start, with the wrong answer. The one that'll leap to your lips inside the minute, and the one nearly everyone dies believing. Go on, you know some physics now. Why don't two things share the one spot?
Easy. Charge. Electrons are all of them negative, aren't they? And like charges, shove each other apart. The table's got electrons across its top, my finger's got electrons on its underside, all the same sign, and they push. The very same reason you can't force the wrong ends of two magnets together. It's just repulsion. There. Can I go home to my breakfast?
You cannot, and I'll tell you exactly why. Because it's the pit the clever ones fall in the hardest. Charge is real, I'll grant it the whole way. It's in the room, it does its bit. When two surfaces truly come together, some of that little shove is charge. But here's the knife that cuts your answer clean in two. Take two atoms that are perfectly neutral, no net charge whatever, as much plus as minus, balanced down to nothing. By your own story, they should sail straight through one another, no charge to push by. And they don't. They still refuse to overlap.
Hold on. Truly neutral, nothing to repel with, nothing to shove, and they still won't share a room. They still take up their space and hold the ground.
Flatly. Every time. So whatever it is that holds the world apart runs underneath the charge, deeper than the pluses and the minuses, and it keeps right on working after you've cancelled the charge away to nothing at all. Charge is a passenger in this business. Something else entirely is at the wheel. And to find it, I have to take you somewhere that's nothing to do with pushing, nothing to do with force of any kind. I have to take you back to the thing you said last week and waved past like it cost you nothing. That the electrons are identical.
Back to that again. I'll own it. I filed identical under things that don't matter and walk straight on.
Most everyone does, and it's the most expensive filing mistake in all of physics. Because that one little word, taken with the whole of its weight, is going to build you a flaw, an atom, and a dead star before this fire burns down.
I remember. You made a great song of it standing right at that door. No speck of paint, no serial number, nothing to tell the one from the next. And I nodded along because they're all much alike is hardly the strangest thing you've laid on me this winter.
And there, right there, is the word I've got to break in your two hands, because it's smuggling a lie past the both of us. Much alike. When you say two things are much alike, what are you truly picturing? Be honest with me.
Two things. Two coins from the same year's minting, near enough twins, but I could scratch a mark on the one, or just quietly keep the count in my head. This one's in my left hand, that one's in my right. Two of them, held apart by which is which.
Two coins, holding still long enough to be labelled, even where you never trouble to scratch the mark. There are two of them, and which is a real fact you're merely choosing not to track. And that picture is exactly the one that fails for an electron. Fails completely, right down to the ground.
Fails completely. That's a strong word from a careful man. You usually hedge.
I do, and I'm not hedging now because there's nothing here to hedge. The coin picture doesn't merely strain for an electron, it snaps clean in two. There simply are not two little labelled things down there for you to keep the count of.
Fails? How, though? You mean I can't keep the count in practice? Too small, too quick, too fiddly, and I lose the thread of which one's which?
Deeper than losing the thread. It isn't that you can't keep track of which is which. It's that there is no which is which there to be kept. Not a label too faint to read, no label there at all. Ask of your two coins, is this the same one that sat here a moment ago, or the other? And there's a true answer, kept or lost. Ask that same question of two electrons, and it isn't a hard question. It isn't a question with a hidden answer. It's a question with no meaning in it whatsoever. Like asking which of two identical nothings is the one on the left.
So they're not identical twins, you're telling me? They're, what, the same twin, somehow filed away in two places at the once?
That is a great deal closer to the truth than anything built out of two separate coins. Not two things that happen to match to the last decimal. a sameness so total that which one stops being a fact about the world. And I'll be careful with you here, the way I'm always careful. This is not me turning poetic on you by the fire, and it isn't a shrug about our instruments being too blunt to tell them apart. It's a hard fact, and we can prove it because the world itself counts differently. Out loud, in the laboratory, depending on whether the things you're tallying carry identities or not.
Prove it, you say? You'll forgive a man for wanting the proof before he swallows a thing that queer.
You're right to want it, and here's the shape of it, kept plain. Line up the ways a pair of things can fall out between two boxes, and count the arrangements. And the tally you get for two things with names is simply not the tally you get for two things without. The world runs on the nameless tally. That isn't philosophy. It's a number you can go and measure.
Counts differently. You mean the arithmetic of the thing, the odds themselves, come out changed, just from whether the two have names?
The very arithmetic of how likely things are shifts, and shifts measurably, the instant you strip the labels off. Two things you genuinely can tell apart, and two you genuinely cannot, hand the world different odds and the world sides every single time with no labels. So we don't guess the labels are gone and hope. We watch them be gone.
All right, that lands as strange, and I'll carry it down the hill. But I'll be straight with you. I still can't see how "there's no which one" gets me within a mile of a hard table. It sounds like a riddle for philosophers, not a flaw for my boots.
Then let me lay the bridge for you, plank by plank. And the first plank runs straight back through a fire we sat at weeks ago. Cast your mind to Feynman's little clocks. Every path a thing might take, carrying its own small clock hand, and you add the hands up, tip to tail, to get the odds out at the end. The amplitude, that little turning arrow.
Ah, you're reaching for the clocks. I wondered if we'd get back round to them.
We could hardly avoid it. Everything since has quietly leaned on them, and they're about to earn their keep one last time on the strangest question we've yet put to the little things.
I remember them fondly. Add the arrows, square the length of what you're left with, out drops the chance. They were the one bit of the whole strange business that felt like machinery I could turn with my own two hands.
Good, because I'm about to turn them on a fresh question, the one that runs this whole morning. Hold two of these identical things and ask me for the amplitude, the little clock, of the arrangement. This one here, that one over there. Fine, now I swap them. I take the two and exchange them, this for that, here for there. And I ask you, what has become of the clock hand?
Well, nothing, surely. If they're truly identical, swapping them can't change one thing I could ever measure. You said it yourself, there's no which one. So the world after the swap is the same world as before it. The clock reads the same.
And you've walked square into the fork in the road. Half right, which is the most dangerous kind of right there is. Here's the subtlety, and it's the pivot the whole day turns upon. What can you actually measure off that little clock? Only the length of the hand, squared. That's your odds. The direction the hand points never came into it once. It was always the length you squared. And the length cannot change, you're right, because the world is the same world. But the hand itself, which way it points, the arrow can do a thing the odds will never see.
Do what? If the length has to sit still, what's left for the poor arrow to get up to?
It can turn, quietly. And if it turns exactly half the way round, a clean half turn, the arrow now points the opposite way, and yet its length is not one whit changed. Same length, same odds, flipped arrow. That's the one move the odds are stone blind to.
A half turn and the length untouched. So the little arrow carries more than the odds ever report back to me.
A great deal more. It carries a direction the meter never thinks to ask after. And nature keeps close, careful books on that hidden direction, even while your instruments stand there blind to it. That gap between what is truly there and what you're allowed to read is exactly where the whole rule has been hiding all along.
Ah, so there are two honest ways to leave the odds alone. Leave the arrow sitting precisely where it was, or spin it a clean half-turn so it points dead backward but measures the very same length. Two ways to change nothing you can see.
And nature uses both. And every particle in all creation is one kind or the other. This is the deepest sorting there is, deeper than heavy or light, deeper than charged or not. Two families. Swap two of the first family, and the arrow comes home untouched, pointing just as it did. Those are the crowd lovers, happy to pile in together, no rule against it. You can heap them into the one state by the 1,000, and they don't mind in the least. Light is built of them. The little pieces of light will crowd into a single state by the billion, all marching in one step. That heaping is the whole secret of a laser.
The crowd lovers. So a beam of that marching light, that's a whole mob of them, content as anything in the one state?
A mob past counting, all in the single state, all in step, and nothing in the rulebook lifts a finger to stop them. For that family, sharing isn't merely allowed, they positively favor it, they crowd toward it. Hold that, the other family is about to do the exact opposite.
A gregarious sort of particle, packs itself in gladly. And the other family, the ones that flip the little arrow backward?
Swap two of them, and the arrow turns its half-turn. Comes back the same length, so nothing you could ever measure has stirred, but pointing backward now. The amplitude returns as its own negative. Those are the loners, the sign flippers. And here is the fact to carve over the lintel of the door. The electron is a loner. Swap two electrons, and the little clock hand turns half the way round. The sign flips. Every electron that has ever been is one of the sign flippers.
A loner. So the electron's the antisocial one, flips its arrow and holds itself apart from its own kind.
The electron and the proton and the neutron, all of them loners, all sign flippers. Keep that last one by you, we'll want the neutron before the end. And notice we've not yet said a word about forbidding anything. All I've told you is that a swap flips their arrow. The forbidding hasn't happened yet, and it's about to happen all on its own.
All right, I'll hold it tight against my chest. Swap two electrons, the arrow flips backward. The length's unchanged, so no meter in the world so much as twitches. And I'll say again what I said before. It sounds like a bookkeeper's curiosity. A minus sign nobody can see, where, in the name of all that's warm, is a hard table hiding in a minus sign nobody can even measure.
Watch, because now I do the one thing that cracks it wide open, and it takes no mathematics you don't already own. Only the nerve to follow two true things straight to the spot where they crash headlong into one another. Take two electrons, and try, just try, to set them both into the very same state. The same place, the same motion, the same twist, that two-faced twist we split a beam clean in two over just last week. Everything about the pair of them identical, right down to the last particular. I want them both in the one state, and I ask you for the clock hand of that arrangement.
Two electrons, same everything, jammed into one single state, and you want the amplitude for it. Go on then, what happens when you ask?
I swap them, and now two things I know for dead certain both come true in the one breath, and they cannot both be true. First, they are the sign flippers, so the swap must turn the arrow half round. The amplitude has to come home as its own negative. That's forced, it's simply what they are. But second, I have put them in the same state, and swapping two things that already sit in identical states rearranges precisely nothing. The arrangement after the swap is the arrangement before it, letter for letter, atom for atom. So the amplitude must come back exactly as it was. unchanged.
But those two fight. One says the arrow flips clean to its own negative. The other swears it can't have moved a hair. A number cannot come home backward and come home unchanged in the same instant. That's a plain contradiction. You've caught your own self out.
Unless, and this is the hinge the whole world hangs from, unless the number is one very particular number. There is exactly one number in all of creation that equals its own negative. One number you can flip clean backward, and it lands right back on itself, not budged in the least. Tell me, what number is its own negative?
0, 0. Flip 0 backward and it's still 0, sitting there entirely unbothered. Nothing else in the whole world survives the trick.
0. So the amplitude, the clock hand, for two electrons crammed into the very same state is not small, and it is not merely unlikely. It is 0. The arrow has no length at all, and an arrangement whose amplitude is 0 is an arrangement that does not happen. There's no length to square, no odds to it. It simply is not there. Not rarely, never. Two electrons cannot occupy the same state, and mark this well. I added no rule on top of anything. I laid down no commandment. It fell out. It fell straight out of two things you already believed, that they're identical and that they're the sign flip kind. Identity plus a minus sign equals a thing the universe cannot write down.
So it isn't unlikely. It isn't merely rare, it's a flat, dead 0.
A flat, dead 0. And a 0 is a wholly different animal from very small. A very small thing still happens now and then, once in a long age of the world. A 0 happens no times at all, not once in the whole life of the universe. That's the wall between rare and forbidden, and two electrons in one state sit squarely on the far side of it.
Let me be dead sure the ground's under me, because that went quick, and I mistrust anything that lands so clean. You didn't decree it. You never once said, "Here is a law, no sharing." You asked the arithmetic for two electrons in one state, and it handed you back a 0 of its own accord. And a 0 means the thing was never there to be had.
That is the whole of the move, and its honesty is the beautiful part. It's not a rule nailed to the wall, thou shalt not share. It's that the sharing arrangement, once you write it out and ask its size, comes to nothing. There's no amount of it anywhere. You can ask for it the way you can ask for a triangle with only two corners. The words sit together well enough, and the thing behind them cannot be built. And it carries a name, this impossibility, from the man who first read it plainly off the world. Pauli. Pauli's exclusion, no two electrons in the same state. But the name is the least of it. The 0 is the whole thing.
Pauli. So there's the man whose name the schoolbooks go and hang it on.
The very one. Though he'd be the first to tell you the name explains not a thing. The exclusion isn't Pauli's decree, it's the world's own arithmetic, and he only had the wit to read it off plainly and say it out loud. Give a true thing a man's name, and half your students walk away thinking the man invented it. He didn't. The 0 did. He just pointed.
Now, let me head off the ghost story before it comes down the chimney, because I can feel it gathering. This is not the electrons somehow knowing about one another, is it? Sensing the seats taken? Agreeing, like two polite strangers on a bench, to leave a decent gap between them.
Good. You've grown a proper nose for the woo. And no, it's nothing of that kind. There's no whisper between them, no signal, no glance over the shoulder, no little electron reading down a register to see if the seat's spoken for. Nothing so cozy and nothing so slow. They make no choice at all. It's simply that the arrangement where they share has 0 amount to it. It isn't a road they nobly decline to walk. It's a road that was never laid down. Don't picture two creatures politely avoiding one another. Picture a possibility with no substance in it, so it never once occurs. The keeping apart isn't a deed they do, it's an absence.
No knowing then, and no pushing either. You swore blind this wasn't the charge from before, gone and put on a fresh coat.
Not the charge. I could switch the charge clean off in my head, make them neutral, no shoving whatsoever, and the zero would stand exactly where it is. This holds a thing apart with nothing at all to push by. It's a fact about counting, about which arrangements the world can write down and which it cannot. And it bites the very hardest, precisely where there's no force in the room to do the biting.
No force, no knowing, no pushing. You've taken every honest tool a man owns for keeping two things apart and binned the whole lot.
Every last one of them. What's left doing the work is the strangest janitor in the world. Not a shove, not a rule, just an arrangement that has no amount to it, and that nothing is sturdier than any push you could name. Now, you asked me for a table.
Then take me to my table. You've been promising it since I was on the doorstep in the frost.
I'll get you there. But the first thing this little zero builds isn't the table at all. It's a thing you've had pinned to a schoolroom wall your whole life and never once suspected of hiding a quantum secret. The periodic table, all those little lettered boxes in their rows.
The periodic table. The thing with all the little boxes I could never make sit still in my head at school.
Nobody could, because they hand it to you as a chart to be memorized, when it's really the fossil of a rule. Every row, every gap, every stubborn box in its place, the whole of it is the shadow of what you just watched happen. Identity and a flipped little arrow.
The coloured chart? What in the wide world has that got to do with two electrons refusing each other a seat?
The whole of it. It simply is this, drawn out long. Picture the atom, a nucleus, and around it a set of states the electrons may sit in, like rungs on a ladder. And mind, they come in distinct rungs, separate and countable, not a smooth ramp. That's Planck's old grain from the first night by this fire, the world coming in steps. It matters more than it looks, that graininess, because without distinct rungs there'd be no such thing as a state for a second electron to be shut out of. Low rungs cheap, high rungs dear. Now, left to itself, what does anything in nature do?
Rolls to the bottom. A bucket of marbles all tumbles to the lowest point it can find. That's the whole habit of the world. Everything sliding to the cheapest rung it can reach. So I'd have said every electron piles onto the very bottom rung together, all of them heaped in the basement.
And that is exactly what you'd expect, and exactly what cannot happen. Because the basement is full after two. The bottom rung is one state of place and motion, and Pauli says one electron to a state. But there's that two-faced twist, up or down, and it counts as part of what a state even is. So the bottom rung takes two, one with its twist up, one with its twist down. And then it is full. Shut. The third electron arrives, finds no lawful seat below, and is forced, not shoved, mind, forced by there being nowhere legal beneath it, to climb to the next rung up.
Two and never a third, because the twist comes in two and never a thing between. That's the very two and only two you split my beam into last week. The same stubborn little two, turning up to run the whole show.
The identical two, and it's no coincidence it's back. It's doing real work now. So the electrons stack. Not because they crave the height, they'd every last one rather be down in the basement, but because the lower floors keep filling two at a time and slamming shut in their faces. And the next two fill the rung above, and the next must climb higher still, shell upon shell.
So the stacking isn't a thing they choose either. It's the basement filling up and forcing the climb.
Forced, every rung of it. And that's the saving of the world, oddly enough. If they weren't driven upward, every atom would be a tiny, dense heap crushed onto the bottom rung, and nothing would differ a jot from anything else. The forced climb is what gives an atom any structure at all to speak of.
Latecomers filling a theatre from the front, then, not out of any love for the front row, but because every good seat behind is already sat in. And I'll wager the shape of that stacking is where you've been steering me.
Straight to it. Where the stacking happens to close a floor off clean, where a shell fills up neat and there's a natural gap before the next begins, those atoms come out calm, content, full up, nothing wanted, nothing offered. They'll scarcely deign to speak to another atom. And an atom 1 electron shy of closing a floor, or 1 lonely electron spilled over into a fresh one, those come out ravenous, all elbows, desperate to hand the stray away or grab one back, to reach the piece of a closed shell.
And that, where the count happens to land, whether your last floor came out even or left one poor soul standing, that's the whole difference between a gas that will do nothing at all and a metal that'll rust and burn and bond.
That is the whole difference. The entire table of the elements is a map of where the stacking closes and where it leaves an atom hungry. The calm ones and the greedy ones, laid out in rows whose very lengths are set by how many electrons slot in before a floor fills. Chemistry, every bond, every fire, everything that has ever lived and drawn breath, is electrons sorting themselves under the one rule. 1 to a state, 2 to a rung.
1 to a state, 2 to a rung. It's a countryman's rule that you could near enough keep sheep by it.
You could keep the whole universe by it, and it does. That one line of bookkeeping, no fancier than counting seats on a cart, writes out every element there is, and the difference between a thing that burns your hand and a thing that won't stir for anyone. The plainest rule you ever heard, doing the very heaviest lifting in nature.
I want to sit on that a breath because it is not a small thing. You're telling me the reason there's such a thing as a substance at all, the reason the world isn't one grey, undifferentiated soup, is that electrons can't all fall to the bottom together. They're forced to stand up in ranks, and the ranks are what make this atom gold, and that one the very air I'm breathing.
The ranks are the elements, every one of them. And there's a second gift folded into the same stacking, quieter, but it sits a good deal nearer your table. It's why an atom has a size at all. If every electron could sink to the lowest rung, the atom would be no bigger than its cheapest state. A dot, near enough. But they can't sink. They're forced up onto the higher rungs, and the higher rungs reach farther out from the nucleus. So the atom puffs up to the size of its filled rungs.
Puffed up to the size of its filled rungs. So an atom's bigness is borrowed. It's the reach of the topmost tenants, and nothing more.
Borrowed exactly. And it's the exclusion doing the lending. That's all I'll say for the moment. I want you to reach the rest yourself. It's a short reach from here.
So the atom is big, takes up any room whatever, for the very same reason it stacks. The electrons can't share, so they're driven outward into roomier states, and the outermost of them marks the edge of the whole thing. That's its size. Nothing pushing it open, just forbidden to fold shut.
Nothing pushing it open at all. Held open by a refusal, not a force. And now you're truly halfway to your table, because an atom with a size is an atom that guards its ground. So bring 2 of them together and start to press.
Press them then. What gives?
To share the same room, the electrons of the one would have to slide into states the other's electrons already fill. And that is the single thing the sign flip forbids. The seats are taken. The zero stands guard over every one of them. So the atoms cannot interpenetrate, and when you press on regardless, the refusal presses back on you. A real outward pressure. It even has a name of its own. Degeneracy pressure. And it is what your hand meets at the table.
Degeneracy pressure. There's a grand mouthful for a thing that just means the seats are full.
A grand name for a plain refusal, I'll grant you. But the plainness is the whole point of it. The seats are full, so the electrons cannot be pushed any closer in together. And a thing that cannot be pushed closer pushes back on whatever's doing the pushing. That pushing back is your table entire, and in a moment or two, a great deal more than your table.
Now hold hard a moment, because I think I've caught you. All morning you've sworn this is no force, no pushing, no knowing, only a zero in the books. And now there's a pressure shoving back on my hand. Where in the world did the shove come from, if there's no force behind it?
The sharpest thing you've asked me all morning, and I'll answer it dead straight, because fudging it here is exactly where the good teachers go bad. It is not a force in the ordinary way. There's no field strung across the gap, nothing reaching over to push, the way a magnet reaches out for iron. What there is a stack of states that cannot be squeezed. To compress the matter, you'd have to force electrons into occupied states, which cannot be done, the zero forbids it. Or else hoist them up onto higher, dearer rungs, and that costs real energy, real effort.
And a thing that costs real effort to squeeze down
Pushes back the very instant you try to squeeze it. That resistance, born of nothing but the counting, of states that will not be doubled up, that is the pressure. There's no little hand behind it. It's the state counting itself, wearing the coat of a force. You feel a push. What's truly there is an impossibility, charging you a toll for the asking.
So the table isn't hard because it's packed tight with tiny bricks. It's hard because to let my finger in, its electrons would have to pile into seats already sat in. And the arithmetic says 0, and 0 means never. So my finger stops.
Your finger stops on a 0. And sit with that a moment, because it's the reason there's room in the world at all. Room for you, room for the table, room for any one thing to be a separate thing from any other. Newton would have told you the table's solid because it's made of solid stuff. Hard little bodies, packed close, matter meeting matter and halting. And he was right that it halts. He simply couldn't have known there's no hard stuff down there to do the halting. The bricks are a haze. The hardness was never once in the material. There's barely any material to speak of. The hardness is in the rule.
So Newton had the right flaw then, and only the wrong reason under it.
The right flaw entirely. A table that stops your hand, exactly as he'd have sworn. He only reached in under it for hard little bricks and came up empty, because there are none down there to find. What stops your hand isn't the stuff of the table at all. It's a rule the table has no more choice but to obey than you have.
So the table isn't being firm with me, it's not even being rude, it's being forbidden. It would let me through if it possibly could, and it physically cannot, because there is no lawful arrangement of the world with my hand and its electrons in the one place.
The table is not being polite. The table is being forbidden. Push all you like. You are asking the universe to write down an arrangement whose amplitude is 0, and it will not do it for you. Not for you, not for me, not for a king leaning the whole of his weight on it. That refusal, multiplied out over every atom in the surface and running back up through your own bones, is the entire sensation of touch. You have never once in all your life truly touched a thing. Not if touching means the stuff meeting the stuff. You felt the exclusion. Every handshake you've ever given was 2 zeros, held a hair's breadth apart.
Then let me keep the two halves sorted, because I nearly muddled them, and you'd have let me stroll off home muddled. The charge, the plain repulsion I marched in swearing by, it isn't nothing. It's genuinely in the mix when two surfaces meet.
It's genuinely in the mix. I'll not strip charge of its share of the little forces right at the point of contact. It's there and it does some real work. But the deep why matter takes up room at all, why a solid can't be squeezed to a speck, why the electrons don't all collapse into the basement and let every atom shrink to a dot. That is the exclusion, not the charge. Cancel the charge, and matter still won't interpenetrate. Cancel the exclusion, let electrons share their seats freely, and matter would fall in on itself in a single instant, every atom to a point, the whole standing world to a dark speck. Charge helps at the surface, exclusion holds the world open.
So keep the ledger honest for me, charge doing a little work at the surface, exclusion holding the world open. That's the split, cleanly.
That's the split, and don't let a soul blur it back together on you. Charge does a little honest labour where two skins meet, and I'll never deny it that. But the reason there is any room in the world for skins to meet in the first place, that is the exclusion, top to bottom. Blur those two, and you've lost the whole of the lesson.
Then I'll push my luck since you've a habit of saving the biggest room in the house for the very last. Is the table the whole prize, this one rule that makes a floor, or are you sitting on something with a longer reach than a kitchen?
I'm sitting on the longest reach there is. And you've earned it, so let me take you there. But gently. It wants saying quiet. That same pressure, the degeneracy pressure, the one that stops your finger at the table, born of nothing but electrons refusing to share a seat, reaches up off your kitchen table and holds up a star.
Off the table and up to a star. That's a mighty long stride for a rule about seating.
The same stride the rule takes out in nature, and it never once breaks step to do it. The very same refusal, the very same pressure, only now set against the one thing far heavier than anything on your table. Gravity, bearing down on a dead star with the whole weight of a sun.
A star. You're about to tell me the thing keeping my coffee cup from caving in is doing a job of work on an actual star.
Take a star like our own sun, but come now to the very end of its life. The fire's gone out. All its long life, it held itself up against its own gravity by burning, the heat of the furnace pushing outward against the crush of its own colossal weight. But the fuel is spent now, the furnace gone cold, and gravity does not tire. Gravity keeps right on pulling, wanting to crush the whole spent star down to nothing. So ask it plainly, what holds the star up now, with the fire dead and the heat all fled? What's left to push back against the weight of a whole sun?
I don't know. If the heat was what held it, and the heat's gone, I'd have said nothing holds it. It falls. It has to fall.
The electrons hold it. The very same electrons refusing to share their states. The very same exclusion that stops your finger at the table, pushing back now against the gravity of a collapsing sun. Squeeze a star that savagely, and you are trying to force its electrons into states already filled, and they will not go. Their refusal is a pressure, and that pressure holds the star. Cold, dark, burnt out, and held open against its own crushing weight by nothing grander than the rule that no two electrons may share the one seat. Such a star we call a white dwarf, a whole sun's worth of matter propped up by the same flat no your table gives your hand of a morning.
The floor of my kitchen and the corpse of a star held up by the identical rule. I want to say it's too neat to credit, but you've never once done neat for its own sake. You're telling me it's the same principle, not a likeness, not a rhyme, the same counting.
The same counting, to the very letter. And now the part that turns the morning solemn. There's a limit to what even the electrons can bear. Pile on more matter, make the dead star heavier and heavier still, and above a certain weight, gravity wins even against the exclusion. The electrons can no longer hold. The star is crushed past what they can carry, driven in on itself, the electrons forced clean into the very nuclei. And what's left, when the dust settles on that catastrophe, is a ball of neutrons. Near enough nothing but neutrons, packed to a thickness you've no picture for.
So the electrons give out. There is a weight, then, that even the great no can't carry.
There is. Even a flat refusal has its breaking strain. Load the star past what the electrons can bear, and gravity drives them under. They lose the long fight at last, and the star falls in past the point where they could ever have held it. And you'd think, wouldn't you, that that was the end of the whole sorry matter?
And that's the end of the poor thing, then. Gravity finally beats the rule outright, and the star just falls forever, down and down to a point.
Not quite the end, because the neutrons take up the stand. This is the turn that gives me a chill every time I say it aloud. The neutrons are sign flippers too. The same family, the same flat refusal. No two of them will share a state any more than two electrons will. So the instant the electrons fail, the neutrons themselves catch the falling star. Their exclusion, their own degeneracy pressure, holds up what the electrons could no longer carry. A whole sun, crushed down to the width of a city, and held by neutrons refusing to double up. A neutron star, the same rule, standing its ground one rank deeper down.
So the exact same no, one to a state and never two, is drawn on three scales at the once. It stops my hand at your table. It holds a burnt-out sun against its own gravity. And when that gives way, it holds up the ball of neutrons underneath. One rule, from a coffee cup to a dead star.
One rule the whole way up. The thing that gives you room to exist. A hand that stops, an atom with a size, a world of separate things instead of grey soup, is the very same thing that keeps a dead star from vanishing clean off the face of creation. And I'll not oversell you the second half. There's real machinery in how a star lives and dies that I've walked us straight past, and I owe you that honestly. But the load-bearing fact, the one to lean your whole weight on going down the hill, is true and clean. The same, no holds both.
A coffee cup and a dead star, propped on the one rule. I keep waiting for the seam to show itself somewhere, and it never does.
There's no seam to show. It's the identical arithmetic, only the stakes climb. On your table, it saves your hand a bruise. Out in the dark, it saves a whole star from falling out of the world altogether. The same no, the same zero, only a different weight leaning its whole self upon it.
It's a strange comfort, that. 10 weeks you've spent taking the solid ground out from under me. The blur, the dice, the half a cat, the room that measures a thing just by breathing on it. And the one thing that finally makes the world firm again turns out to be the strangest rule of the whole lot. A minus sign, a zero. There's no seat, so nothing sits there. And that is the flaw. The world is held open by a plain impossibility.
Held open by an impossibility. I'll not try to improve on that, so I'll leave it stand exactly where you set it. The flimsiest thing you own, that electrons have no name, that swapping two of them flips an arrow you can't even see, is the very thing that makes matter refuse to be nothing. Follow the blur the whole way down, and it turns out to be what builds the wall.
Then before you swing the door shut on me, the honest folding of the sheets, the accounting you always make me take, so I don't go strolling home down the hill claiming the morning earned me a great deal more than it did. What did we not do this time? Where's it left folded?
3 sheets, and I'll name each one plainly, so you don't find it missing later and think I hid it from you. First, I told you the electron is the sign flip kind, and I never once told you why. Why it's the loners that flip and the crowd lovers that don't. There's a deep reckoning that ties that flipping to the twist itself, why the two go hand in hand at all, and it's a whole fire of its own, a good way further up this hill than we've yet climbed. I needed you to believe the flip this morning, not to earn it.
So even the why of the flip is a sweet you're keeping back. You never do run short of pockets, do you?
Never. And it's the one honest way to teach a thing this deep, a pocket at a time. Empty them all onto the table at once, and you'd carry not a single one of them home. So yes, why the loners flip and the crowd lovers don't is banked, and it's a fair climb off yet.
Banked then, like all your banked things. You'll cash it in the end, you old miser. And the second sheet?
The star. I gave you the true bones, electrons holding a dead sun, neutrons holding what's left when the electrons fail, and I stand by every word of it. But how a star burns, how it dies, precisely where the weight tips past what the electrons can bear, that's a furnace I only pointed at through the window. Bones this morning, not the whole body. And the third is the door itself, and I can hear you've already found it.
I have. All morning you've had me stacking electrons into states, sitting them down on rungs, as though a state were a little numbered shelf you slide a thing onto. And you've never once told me what a state actually looks like. You've done it every single week. Leave one word deliberately unturned and set it there by the grate to cash me later.
Because it's the right question, and it's next week's whole business. I've had you stacking electrons into states and shells for 2 hours, but where is an electron in an atom, truly? It's a spread-out wave that cannot be pinned to a spot. You've known that since the 2 slits. So a state isn't a shelf, and it isn't a little orbit either. It's a shape the wave settles into, a cloud with a real form to it. Some round as a ball, some drawn out into lobes and halos, and every one of them wearing the shape it wears for a reason you'll be able to follow with your own eyes.
Hold on, you've just slipped a whole new world in under that last sentence. The state itself has a look to it.
It has a form you could draw. Some like a plain round ball of mist, some pinched into a pair of lobes, like a thing knotted tight at its middle. Real shapes every one, each wearing its form for a reason.
A shape. You're telling me the electron in the atom has a shape, that the wear of it, blurred as it is, comes in definite forms.
It comes in forms, and the forms are why chemistry has the geometry it does, why molecules bend and hook and lock together the way they do. We've spent this whole morning on the rule that fills the states. Next time we look at the states themselves, the true shapes of the atom, the clouds the electron actually lives in, and why they wear the shapes they wear. Next time, the shape of the atom.
Then here's your whole cold morning back in a single breath, the way you always make me give it before you'll let me go. I climbed up demanding to know why a table is hard, dead sure it was only charge, like magnets, wrong ends pushing. And you took the charge clean off me, showed me 2 neutral atoms that still won't share a room, and drove me somewhere I'd never once have wandered on my own. That electrons have no name and no which one, that swapping 2 of them turns a little clock hand a half-turn backward, and that from that flip alone, no rule bolted on top, 2 electrons can never share a state, because the arrangement where they do comes out to nothing at all, to 0. And out of that 1 0 fell the whole standing world, the periodic table, the size of every atom in me, the reason there's stuff instead of soup, the reason my hand stops at your table. And then, saved for the very last, you old miser, the reason a dead star doesn't fall clean into nothing. The floor and the star propped on the same flat no. So keep your impossible seat warm there by the grate. Next week I'll come back to learn what shape a nothing you can't pin actually takes. And I'll be at your door before the birds.